Hi, I'm Adolph Oliver, and this is the video clip about solving 3x3 systems of linear equations. Now, what do we mean by a 3x3 system? Well, it has three equations in three variables, like this example given right here. We've got x, y, and z in each equation, and we have three equations. Now, if it turns out that these equations are all good, meaning they're independent of one another, you can get an xy solution that solves all of them at the same time. This is, of course, what is known as the system solution. This would be the answer to the word problem that produced these equations. Well, what's the method that's used here to solve these? Okay, elimination is usually used to solve the system, but substitution is sometimes also helpful. In fact, the idea here is anything that really helps you move toward the solution is definitely usable. Not remember that real problems have real solutions, so your equations should not have a variable disappear during your solving process. As we've seen previously in 2x2 situations, this indicates that we have a bad solution and at least one of your equations is not correct. Well, let's go back for a second and just mention how we're going to tackle this. We have these three equations. Okay? There are three possible pairings you can make of these three equations. You can pair the first and the second, you could compare the second and the third, and you can compare the first and the third. The key to solving a 3x3 system is to use two of these three pairings. Your choice which ones you want to use. Use two of the three and eliminate the same variable between those two pairings. Now, what you want to do is take a look and see what pairings would make your job the easiest. For instance, looking at these guys right here, it would be easy to eliminate the z's between these. I would probably take the first pairing between the first and second equations. If I just combine them, the z's would go out. And if I did that between the second and third, the z's would go out there. Now, the idea again here is you have to eliminate the same variable between the two pairings that you pick. And when you do that, you'll end up with two equations and two unknowns, a 2x2 system, which you've had practice in solving before. Again, it's your choice which pairings you take, but you have to take two different ones to be able to get all the information of the system to get the correct answer. Well, here's our first example. And notice it's kind of like the one we just talked about. There is a variable, and it happens to be the same one, the z's, that look like they'd be pretty easy to eliminate. Now, you're not always going to have things quite this easy, but let's go ahead and make use of it. Now, by the way, you could have also eliminated the y's. They wouldn't be too hard to do. The x's would be a little bit more messy here. But let's go ahead now and eliminate the z's. So I'm going to take the first and second equations as one pairing and the second and third as my other pairing. So here we go. The first pairing here, and I'll just call these 1 and 2. Number 1 here, let me write the first equation, negative 5x plus 3y, okay, plus z equals negative 9. Well, if I write the second one down here exactly the way it is, I don't have to multiply it by anything. The z's will knock themselves out. So like I said, you're not always going to get something this nice, but hey, it's pleasant when you do. Okay, so notice combining these two guys now, the z's cancel out, and I end up with negative 7x plus 2y equals negative 13. Okay. Now, let's turn around and do the second pairing over here. Okay. And I'll write the center guy first, negative 2x minus y. Okay. Continuing on here, minus z equals negative 4. Okay. And then the second equation underneath of the pairing, 3x minus 4y plus z equals 20. Okay, let's combine these guys. Looks like I get x, okay, minus 5y. Okay. The z's cancel out, as we hope they did, and equals 16. Okay, here's the key now. Notice that you have two equations here in two variables, and they're both in the variables x and y. We can now solve this as a 2x2 system. Now, the easiest thing is probably to eliminate the x's, because I've got negative 7x here, and if I multiply this guy over here by 7, I'll have positive 7x, and the x's will go out. So let's go ahead and try that. I'm going to take this first guy here and just write him the way he is, because I don't want to change anything here. So negative 7x plus 2y equals negative 13. Okay, but the second guy now, I'm going to write him down here, and I'm going to multiply by 7 because I want to get plus 7x, so the x's will eliminate. Okay, well, here we go. 7 times x, and it's positive, 7x. 7 times negative 5 is negative 35y. Be sure when you multiply that you multiply everybody going across. Remember, this is a balance scale thing. So here we go. 7 times 16, I think is 112, isn't it? Okay. So now, here we go. Now, by the way, whenever you get things like this, you get your calculator out and double check and make sure you're correct. Well, anyway, we doctored this up so that we would eliminate the x's, and notice that's indeed what happens here. So the x's are gone. I get negative 33y equals, looks like 99. Well, divide both sides by negative 33, and I think we get here, what's it, y equals negative 3. Okay, there we go. There's our first solution. Okay, well, now we got to work back and get the other variables in here. So let's see, where's a good spot to work with this? How about using this guy here? Now, you can use any equation that's got y and x in it, so both of these would work. This one looks like the simpler one right here. So what I'm going to have is I'm going to plug my negative 3y in here to be able to come up with x. So I've got x minus 5 times the negative 3 equals 16. Okay, well, this is x equals, let's see, what do we got here? Positive 15, I should say x plus 15. I jumped the gun a little bit here. X plus 15 equals 16. Okay. Well, take this plus 5 and jump, or plus 15, jump it over here as negative 15. Looks like x equals, let's see, what's it going to be? Just 1. Okay. So notice we previously got y equals negative 3. We now have x equals 1. So the only thing left to do is go after z, and we can use any of the equations that we started with up here. Let's see, which one looks like it has the lower numbers? maybe the guy in the middle here. You can use any one of these here, so you'll get the same answer as long as you don't make any mistakes. So let's write this down, and we'll plug in x and y as we go along. Negative 2 times x, which is 1, minus y, and y is negative 3, minus z equals negative 4. Okay, well, let's clean this up a little bit to find out what our z is. Negative 2 times 1 is negative 2. Negative times negative 3 is positive 3. And then we have minus z equals negative 4. Well, combine these two guys, I get 1 minus z equals negative 4. Okay, let's keep going on this. Take the plus 1, that's what this is. Move it over here to the other side is negative 1. And we get negative z equals negative 5. Divide both sides by negative 1. Okay, and we end up with z equals 5. Okay, well, here it is. We now have our system solution. Okay, the system solution is x equals 1. We always write it in alphabetical order. Y equals negative 3, and z equals 5. Now, if you took this system solution here and plugged it back in to the original equations up on top, you'd see that it balances all three of these, so it is definitely our system solution. Okay, here's our next example, and notice that we have some variables missing here, and we can often utilize this to speed up our solution a little bit. So what I started doing here was rewriting these guys so we can see exactly who we have and who we don't have. So the first equation here, 2a plus 12b, okay, minus 4c equals 19. Okay, then the next one, negative 30a, but notice now we have no b's, so I go out to negative 6c equals negative 7. The third one, negative 6a minus 6b equals negative 11. Well, the second equation doesn't have any b, and the third equation doesn't have any c. So we could use one of these guys as a starting spot here to be able to get down to our 2x2 system. Well, looking ahead, if I took this second equation with the b missing, it would be pretty easy to eliminate the b's between the first and third. Remember, you have to take 3 pairings, but if you have one of them already reduced down with a missing variable, that counts as one of them. So here we go. Let's indicate now that what we're going to do is make use of this second guy, and I'm going to rewrite him now. Negative 6c equals negative 7. Okay, what we have here is no b. Okay, then I'm going to pair up the first and third guys here. I want to eliminate the b's. Well, I have plus 12b up here, so if I multiply this equation by 2, I'll have negative 12b, and they will eliminate. So let's do this. First, rewrite the first guy. Here he comes. I've got 2a plus 12b minus 4c equals 19. Okay. Now, the second guy I want to change to negative 12b, so I'm going to multiply this second one here by 2. Okay, and that'll give me negative 12a, negative 12b equals, looks like negative 22 over here. Okay, well now let's combine these, and remember, we did this so that the b's would eliminate, and they certainly do. So what do I end up with here? Looks like I've got myself here 10, let's see, negative 10a, okay, yeah, there we go, plus 2a minus 12 would be negative 10, the b's go out, negative 4c equals, looks like negative 3. So, now this is my second equation, which has the b missing. Remember, I got this give me up here. We got lucky, we had one of the equations already missing b. Now, what would be the easiest thing to eliminate here? Probably looks like the a's, because I've got 30a here, and all I have to do is multiply this guy by 3 to make 30. Well, now here's one of the things that you want to make sure, and that's that you have to have the signs opposite, so when you combine them, what happens is they eliminate. So, since this is negative 30a, and this is negative 10b, I've got to change this to positive 30a. I'm going to multiply here by negative 3. I've got to multiply everybody by it, so let's do it carefully. Negative 3 times negative 10 is positive 30a. Now remember, these eliminate now. That's what we wanted. Negative 3 times negative 4 is positive 12c. And negative 3 times negative 3 looks like it's positive 9. Okay, well now, let's combine these. Remember, we set it up so that the a's would cancel out. There they go. And negative 6c plus 12c means we have 6c equals, and negative 7 plus 9, I think that's positive 2. So c equals 2 over 6, or reducing this, yes, 2 goes once here and 3 times here, c equals 1/3. Okay, so here we go. There's our first solution. Now, to get the next variable, the easiest equation is to go back up to the original guys up here, and let's grab the one that has just a and c. Okay, and I'm going to plug in the c value and then solve for a. So here it goes. I've got negative 30a minus 6 times the c value, which is 1/3, okay, equals negative 7. Now let's double check that. Negative 30a minus 6 times c, c is 1/3, equals negative 7. Okay, looks good. We can do some cross-canceling here. 3 goes once here and twice there. So what I end up with now, as I continue on with this, is negative 30a minus 2 times 1, which is minus 2, equals negative 7. Well, take the minus 2 over as positive 2. Looks like I've got negative 30a, okay, equals, what is it going to be here? Looks like it's negative 5, huh? Okay, so now let's divide both sides by negative 30. Here it is, okay. And after doing that, I get a equals, there's 2 minuses, so it's a plus, 5/30. Okay, now of course I can reduce 5 once here and 6 times here. So I end up with a equals 1/6. Well, in this particular system, we're getting fractional answers, and of course remember, in the real world your answers are always going to be fractions and decimals. You only tend to get nice integer solutions in math books. Well, anyway, there's still one more that we've got to solve for, and that's b, and the easiest place to get b is to go back up to the original equation up here, which has just a and b. So that's this guy right here. Let's grab him and bring him down here. And so I've got negative 6 times a, and the a is 1/6. So I'm substituting that in. Minus 6 times the b, remember we're solving for b, equals negative 11. Okay, that was our first equation up here. Yeah, let me scoot this up so you can see what I'm doing here. Let's point this out once again. Negative 6 times a, which is 1/6, okay, minus 6 times b, we're solving for b, so I leave the b, equals negative 11. That's from one of the original equations up there. Well, here we go. 6 goes once here and goes once here. So I end up with, looks like negative 1 minus 6b equals negative 11. Take the minus 1 over as plus 1. Negative 6b equals, looks like it's negative 10. Okay, well now let's divide both sides by negative 6, and I get b equals, and this negative 6's cancel out, 2 minuses give me a plus, 10/6, and of course we have to reduce this. 2 goes into 6 3 times, 2 goes into 10 5 times, so it looks like we end up with getting b equal to 5/3. Okay, well there we are. There's our whole system solution here. If you turn around and take it, remember you give it in alphabetical order. So the system solution, okay, here it is. System solution, the a value is 1/6, the b value is 5/3, and the c value is 1/3. Okay, take these guys and plug them into the original equations way back up here, and they will balance all three of these. So it is, in fact, the system solution that we're after here. Well, remember, the key again, just to emphasize this before we look at our last example, is to take two different pairings. If you happen to be lucky enough to have an equation where one of the variables is missing, that counts as one of the pairings right there. Pair up the other two to continue on, and that's what we did. Worked our way slowly on down here and came up with the solutions to all of these, which in this particular example turned out to be 3 fraction values, but that's not uncommon at all. Well, here's one last example to look at, and again the first thing I'm going to do is rewrite the variables so the equations are in standard form. The first guy is okay. Let me just write him down. Negative x minus 3y plus z equals negative 19. Remember, to keep us from goofing this up, we want to have x, y, and z in order on the left, and whatever the plain number is on the right. Now, this is extraordinary to get just a single variable here already given, but it can occur like it did right here. So z equals 2. Well, I think we know what the value of z is. Now, let's clean up the third equation. On the left side, we already have the x, so I'll remind us it's plus. The minus 3y will come over as plus 3y. The minus 4z will come over as plus 4z. And we keep the 7 on the right. Okay, well, definitely we're going to use here the value of z equals 2, and what we need to do is eliminate one of the other variables here in the other two equations that exist. The y's will go out really nice here, so let's just combine these two equations the way they are. I'll rewrite them next to each other here. Negative x minus 3y plus z equals negative 19. And then the second or last equation here, just as it is, plus x plus 3y plus 4z equals 7. Well now, remember we did this so the y's would go out, but look at what else happened. The x's also went out. So what we have left here is just z's. 5z equals what? Negative 12. Well, there's no way to solve for the other variables here. When your other variables disappeared, it only takes one of them to do this. In this case, two of them did. Then, okay, when variables disappear, what that means is you have a bad system, and that means that some of the planes, remember when you have three variables, we're not talking about lines anymore, we're talking about planes in XYZ space. Two of them could be parallel, two of them could be on top of each other. There are all kinds of more things that can happen when you're talking about planes, but the key is if you have a bad system, okay, there is no solution. So whenever your variables disappear, like we just had right here, there's no way we can solve for anything more. There's no x's and y's that exist. So you simply say no solution.